Okay, back again. And this time, let's let's see how to put together this subtraction mechanism for the full adder and subtractor. Now I'm just going to take it off of here, and I'm not going to bother counting things out like I did before, because that was rather er, time consuming. So I'm just going to add it onto here. So this is the full adder which we did last time, and this is the output of an exclusive OR gate. Now I need my sticky pistons back, and I'll just forego all of that. Torches, I've got redstone. I don't really need comparators. Don't really need those. Do I want levers? I probably will want levers. Okay, let me get everything sorted out. Okay, I think I've got everything together, and there's a sticky piston there. Oh yeah, and by the way, the subtracting mechanism, it's composed of an exclusive OR gate leading into a half adder. And I'll be rechecking this as I go along quite a bit. Okay, so that goes like that. So probably a lot of cuts to this video because I just put, when I was going through this, I was putting it together the first time, so it could probably be compacted, but not that I have attempted any further compaction than I was able to do at the time. Well, okay, so I had it. There were two blocks here. It went up and down again, and this came down. This leads down to lead into the next half adder. Right down here. And I believe I had it like this. I'm trying not to go back to my original setup, and there is one of those there. There's a torch here. No, not there. There's a torch there. And that's coming in from the previous adder. And that's basically how that goes. So this just leads into the exclusive OR gate. And if you don't know the operation of a half adder, it's like a full adder, except it has no carry-in. Or, well, did it have a carry-out? Probably. I'm not quite sure. This design, it's got the output, and then I've also got one of the inputs leading into another output. And then that goes there with the redstone dust. Over here is some... No, that does not go there. That goes there. And then this is just an AND gate, which leads into the It leads into the next half adder like this. And then that just goes up to a torch tower, like so. And then this is that torch. So over here we can put the same over here. Right there. Stone bricks for support. Oh, I love this fire button so much. And I just broke a lever. Just a lever, don't need to worry about it. And I don't really need that block for in the design over here. What I've got over here, I've just got a torch tower leading up to that input of the full adder. Okay. So that's how it's supposed to be. Wait, no, that is not how it's supposed to be. This doesn't exist. That's where the thing leads into. So that is turned on, and over here, of course, for the exclusive OR gate, we've got that set up, and that makes exclusive OR gate, and this redstone line, and that powers that piston, and then this comes from the exclusive OR gate. Let me go check just exactly how that worked. Okay, I just saw a method of compaction that I did not quite realize. Wait, let me rethink that. I may need rethinking of that. Yes, I do need rethinking of that because that would go there and that would be powered by that torch. So no, this does have to come down over here. This comes from the exclusive OR gate, and basically what the exclusive OR gate is doing is it is acting as an inverter which you can turn on and off. So by now you've probably seen, well, by now this whole circuit has 4 exclusive OR gates, and of course with exclusive OR gate it comes in like that. Here's your bit 1 input. Here's your bit 2 input. And then here is whether you want to add or subtract. So for subtraction, what you do with subtraction, since you don't have a minus sign in these physical circuits, is that you it's called the 2's complement, where if you've got, let me represent with levers. Let's just say I have this 8-bit number, and it doesn't matter what number it is. So that's your 8-bit number. 2's complement. First you take the 1's complement, which is you invert everything. Well, each bit separately. No, that does not get inverted. So there's... Hey, let me grab a sign and label these. One moment. Okay, so here's the given number, the 1's complement, and to get the 2's complement, what you do is you take the 1's complement and you add 1 to it. So that one gets switched. Those two... Actually, no. These are supposed to be the same as that. So this would then be the 2's complement. Because having a... Wait. If the lever is up, then it signifies a 1-bit. Actually, let's change the most significant bit to a 1. And then that would turn those. So to get from the 2's complement, well, no, from the 1's complement to the 2's complement, you add 1, which in this case is you add 1, that goes to 0, this one goes to 1. And then here's your 2's complement of this given number, which happens to be, that's a 2, 4, 8, 16, 32, 64, 128. Wait. Yeah, 128 plus 64. Let me do this. 128 plus 64 plus... Was it... Wait, let me go back to there. One moment. Okay, so T. Since we've got 128 plus 64 plus 32, 16 plus 2. I mean, that's right. 1, 1s, 2s, 4s, 8s, 16s, yes. And that will equal 2, 6, that's 8, then 12. Well, that's 12 plus 8 is 20, so there's a 0. 1, add a 2, that's 3, plus 6 is 9, plus 2 is 11. So 0, 1, and then 2, 1, 0. Oh, wait, am I thinking correctly? 210. So that's this number. The 2's complement is this, and when you add them together, because this you already added 1, what you get is the as if you subtracted it. If you added a number to its 2's complement, you would get 0. Because if you add the 1's complement to its number, you get all 1's. And that's basically how you do a 2's complement. And this machine, the half adder, the exclusive OR gate, you choose whether you put in an inverted signal, and actually over here, this would be coming in from your other, also from here, so this would also be used to activate the 2's complement. And that's how you get the entire system tileable, or expandable would be a better term. So then the 1's complement of 0, the 2's complement of 0 is 0. The 2's complement of 1, well, no, this is 0 minus 1, which would be, technically you're not supposed to do this, but the most important thing about it is that when you do the 2's complement, when you subtract numbers, you can not have this carryout bit, because that throws off the calculations. You just pretend it doesn't exist, because it's what makes the 2's complement work, and that is all. Well, that's all for the episode, I guess. Okay, so the 2's complement, you just get when you subtract a number from itself, you just get this number lit up. Just because it's the overflow and you don't see it, so 1 minus 1, what I'm really doing is 1 plus 1, but I'm not looking at this bit at all. So what I see is 0. And that's how the 2's complement works. And that will do it for this episode of my Minecraft creations, and maybe eventually I'll do a tutorial on how to make it cumulate, for which you would need more bits. So with that, I am out. Have a good day, and I hope you enjoyed this tutorial.